Okay, today's lesson is about simulations, which for many of you who did the 12 stats course last year will be familiar with, as we did an assessment on it. But for those of you who came from the Maths A course, maybe that you haven't come across it before. It doesn't go in as in depth as it does in the 12 stats course into some simulations, but sometimes questions are related to simulations in the probability concepts paper. So, just a bit of background. So simulations imitate the true probability of a situation. They use a device to imitate the probability of an event. For example, if we know from past experience using experimental data that the chance it rains on any particular day is 1/3, then we can use a dice to simulate whether it rains or not on a particular day. And that's if we make the decision that if we roll a dice and we get 1 and 2, we can say it rains. And that's because getting 1 or 2 on a 6-sided dice is the same probability as a third. So we use simulations when it's really difficult to calculate probabilities, or theoretical probabilities are really hard to measure. They tend to be like observations over a period of time. So it could be the probability that a bus comes past in the next hour. That's a really hard thing to measure theoretically because we don't know how many cars are going to go past in the next hour. What we can do is sit there and actually measure them and carry them out. Or when it's something that the experiment's too difficult, we can try and model the probability from what we've observed before. So a model, we also use simulations when a model is difficult, time-consuming, or expensive. So I thought probably the easiest way to look at this is to go straight into looking at an example of a simulation. So this is a bird task simulation looking at starting off with a pair of birds. What is the probability, or how many adult birds will come from that one pair within the year? Now that's obviously a difficult thing to calculate because there's a number of steps that go in between. But what is very easy is that if we look at past experience or the past numbers that we know, we can put those together to then work out what the result is. So in the spring, a pair of birds will lay any number of eggs between 4 and 16. Any egg that hatches will produce 1 chick. Being a vulnerable chick is dangerous, so not all of them will survive in the first 3 months. If they do, however, they'll become a fledgling or young birds. And then the following spring, they're considered an adult. And then the adult birds will pair up to make their next family. So if we're asking the question, what's the number of adult birds that will come in the next spring? That's something that's obviously going to take a bit of time. So we would have to wait a whole year to work out those answers. Or using previous information, we can have a look at trying to predict or simulate how many we would expect to get. So obviously this problem's got a number of stages. The first thing is laying the eggs. So you were told that at the start the number of eggs that a bird will lay is between 4 and 16. So to calculate that, what we're going to do is roll 2 dice onto the table, and if you are looking at the dice on the table only, add up the visible spots, then add 4 for your total. This will be the number of eggs you produce. So in a way, what we're trying to do is randomly produce the number of eggs between 4 and 16. So I'll just get some dice and we can do that. Okay, here we go. So I rolled a 4, a 3 and a 1 on the 2 dice. So that means there are 8 eggs. Probably should use ticks. So there are 8 eggs that are produced by the bird, and these are all the ones we're not going to worry about. So that's the first stage. So 4 eggs is what we ended up with. Sorry, I said in the last one we had 4 eggs at the end there. It was 8 because we added the 4 on. So stage 2 is then of those 8 eggs we've got, how many of them will hatch? And we know from previous experience that 83% of the eggs will survive and produce a chick. So what we're going to do in our simulation is we're going to go to each, in stage 2, is we're going to go to each egg, and in turn we're going to see whether it will hatch or not. So again, we roll 2 dice, and if the 2 dice add up to 7, then it will mean that the egg didn't hatch and the chick didn't survive. If we get something other than 7, we will say that the chick survived and was hatched out of the egg. So looking first of all, egg number 1. Okay, so we've got 6 and a 6, so that's a 12, so that egg survived. Got a 6 and a 5, so that egg survived. We've got a 5 and a 1, so that egg survived. We got a 6 and a 3, that egg survived. We got a 6 and a, 3 and a 3, so that adds to 6, so that egg survives. We got a 5 and a 1, so that egg survives. We got a 4 and a 2, so that egg survives. And the last one, a 4 and a 1, which that egg survives. So all 8 eggs survive successfully. So you can kind of see with the simulation that we're doing is that we're using data to mimic the real life situation, which matching with our device, which is the dice. You could quite easily repeat this with a random number chart or a calculator or anything like that. In fact, it's much better than dice because anything that's not a probability of a sixth, it makes it really difficult to be able to get those. But you can see the inventive ways that in this simulation we can get things like 83%. So all 8 survived. Okay, so stage 3 is looking whether the chick survives. So for each chick, there is a 60% chance of survival. Take each hatched egg and in turn and see if the chick survives to fledgling status by rolling 2 dice again. If your dice if your dice total was 3, 4, 5, or 6, then your chick dies, unfortunately. And then move on to the next chick. So the other way to look at this as well, if it's 3, 4, 5, or 6, it dies. Then it's 1 or 2. Obviously, 2 dice you can't get 1. So if we get a 2 or 7 plus, we end up with the probability that we need. So rolling the dice again. So chick number 1, we get a 7, so it survives. We get an 8 for the second one, so that survives. We unfortunately get a 5, so a 3 and a 2, which means that trick number 3 didn't make it. 5 and a 6, which is 11. A 6 and 3, which is 9. 4 and a 4, so that gives us another one survival. A 10, so 4 and a 6. And the last one, Snake eyes, double one. So that means that our 8th chick didn't make it. So we've lost 2 of our 8. So there's 6 that come through to become fledglings. Okay, so it's starting to get serious now that the fledglings then see if they survive to adulthood. So for each fledgling, there is a 10% chance of survival, so quite low. Take each fledgling in turn and see if they survive to become adults by rolling 2 dice together. If your fledgling survives, you roll a total of 9. You roll anything except a total of 9. You've just fed the cat. And try the others. So let's take a look at the first one. So we're 11. So the first fledgling didn't make it. So we ended up with 6. Oh, so that's wrong. Okay, 5, they didn't make it. 11 didn't make it. 7 didn't make it. 8 didn't make it. Come on, the last one. 9. What are the chances of that? And I shouldn't have done the third one there because they were already dead. So from that, we ended up with 1 that became a fledgling. The last bit is adult survival. For each of the fully fledged adults, of which we've only got 1, there's a 50% chance it will survive long enough to breed. Take each new adult in turn and see if it manages to pair up and breed by rolling just 1 of your 2 dice. In order, for it to be able to breed, it must roll and show a 1 or a 3. So 2 dice and 1 dice. We've got to roll a 1 or a 3. And unfortunately, we got a 4. So that means the total number of breeding animals we ended up with was 0 in our simulation. Now, so there's a couple of things to talk about with the simulation and what's the point. Is though, first of all, we were able to simulate the whole yearly cycle or breeding cycle of this bird in a matter of 10 minutes. From that, can obviously get some clear information that the number of eggs that we produce is a problem. The life stage going from a chick to a fledgling is really dangerous, and that's where you might need to protect this bird to increase the breeding numbers. But also, we can get information quite quickly from doing this. The other thing to take into account that this was just one trial of a simulation. For simulations to be accurate, you need to do them more than once, and that's where over the years the increased use of computers and things like that has been sort of driven by the fact that computers are really good at taking simple tasks like rolling dice or producing random numbers and doing it over and over again really quickly. So you could program a simulation relatively quickly and produce 1,000 results. Because our one trial, even though we ended up with 0, that's not going to be the most accurate result. The more trials you do, and this is what we found of the probabilities of things we can work out the theoretical probabilities of, the more simulations you do, the more accurate or the more closely that the experimental probability fits that theoretical probability. So what I wouldn't be comfortable in doing is saying that the likely outcome of these birds is that they produce no breeding adults, I would have to do more simulations to be confident in that answer. On the OneNote content library page under simulations, there's actually a paper version of this if you'd like to give it a go yourself. Otherwise, there's you can do the questions out of the workbook.